Hello everyone. In today's Computer Network Lab program, we'll discuss the program 1, that is first program of part A. So it is actually network simulator programs. So first program goes like this: simulate a 3-node point-to-point network with duplex links between them. Set the queue size and vary the bandwidth and find the number of packets dropped. So we have to actually have a point-to-point network among 3 nodes with a duplex link, and we should actually vary the queue size as well as the bandwidth, and we have to find out the packets that are getting dropped. Let us see how can we write the program for the same. Let us see the logic now. How can we write the code for the program that we discussed? So before this, I just want to talk about the prerequisites. You should have NS2 installed on your Ubuntu. Okay, so that you have to make sure that you have your network simulator 2 installed on your Ubuntu. Then you can write this code and then execute it on Ubuntu. So let us see the code. Okay, set NS new simulator. What exactly is this? We are actually creating the simulator. Okay, here we are actually creating the simulator. So what does it, what is this NS? This is an object. Okay, an object called NS will be created with the class, within the class simulator. Okay, within the class called simulator with the help of the operator new. So that means this is an object which is actually getting created within the class called simulator with the help of the operator new. Okay, so we are creating the simulator now. We have created it. Now we are actually creating 2 important files. The first one is trace file. The second one is NAM file. Okay, NAM is nothing but network animation. Okay, this is the network animation, that is NAM file, and the other one is trace file. So set ntrace open prog, that means program1.tr. Trace file extension is tr, and we are creating it in write mode. That's why this W is for. So we have created the trace file here with the name program1, that is prog1. So, and then here we are creating NAM file, network animation file, open program1.nam. .nam is the extension. We are creating that in the write mode. So what are these 2 lines then? $NS trace all $ntrace. Even here same thing, but it is for NAM file. So what are these 2 lines are? See this $symbol, right? It indicates like it is actually content of NS. What does it mean? It refers to your simulator class. So whenever you use this $symbol, that means you are actually referring to the simulator class. Okay. So here all data, what are we doing in these 2 lines? All data that we got with help of the trace and NAM file. Okay, all the data will be pushed into a simulation. So next we have a finish procedure here. We will not worry about this procedure. It starts from here and ends at here. I'll just get back to it whenever I am executing it. Okay, as of now I'll just skip these lines from here to here. So let us see what comes next. Whenever we call this procedure, right, I'll just come and explain it here. So yeah, after that we have, so before that executing those lines, we have create 3 nodes. That means I am creating 3 nodes. As per my program, I need to create 3 nodes. I am using set n0 and then $NS node. This is the command for that. Okay, and you are actually, this is the syntax for it, and you are creating the node here. Okay, you are creating the n0, and same way n1 and then n2. So that's why I have 3 lines here, and then later I am actually labeling it TCP source, TCP sink. This is the sink, TCP sink, because from here I am actually sending it to this particular node. So this is my source and this is my sink. Set color. So color, I am just setting the color one blue. That means like whenever I'm sending the packages and then acknowledgements, right, packets and acknowledgement and packets that are going to be dropped from here, all those things will be in blue color. Here this is like just an like you should get this imagination whenever you read the program. That's why I have put it here. Okay, anyway, later we will see this whenever we are executing, how exactly we get this output. So these are all the packets that you are seeing, right? These are all the packets that you are sending from 0 to 1, and this is actually from 1 to 2. So these are all the acknowledgements. 2 to 1, this is the acknowledgement. 1 to 0, this is the acknowledgement. And packet drops, so you can see it from here. From source itself, actually sometimes, most of the time, you will actually see the packets dropping out. Okay, so yeah, I have named it, I have colored it. Next, what am I supposed to do? Create links between nodes. I just have the nodes here, right? I need to create the link between them. So see here, to create the link, right, I need 7 parameters. The first one is anyway simulator class, right? So this is simulator class. And then what I have, type of link. This is the duplex link. That means it is full duplex. You can send as well as receive in the same time. So this is actually duplex link. Then you have what is this one then? Sender node. From which node are you sending? And then this is destination node. To which node are you sending the data? And then you have bandwidth. Network bandwidth. That link, what is the bandwidth of that link? It's 1 MB. Okay, and then simulation time required. This is 10 milliseconds. What is the simulation time to reach from here to here? It is 10 milliseconds. And what is the type of the queue which you have used? It is drop tail. Drop tail is the type of the queue. So yeah, we have created, this is one link and this is one link. So 2 links we have created it in 2 lines. So make the link orientation. Like from which, like how are you orienting it? From this here to here, right? If you just draw an arrow mark, you can just consider this as an arrow mark. So from 0 to 1, I mean it's my node 1 is towards its right? So how is the orientation? Just see here, duplex link N0 to N1 right orient. That means N0 will be here and N1 will come towards its right. And here N1, N2. N2 will actually come towards right side of the node 1. That's what the orientation we are doing it here. Next, we are actually setting the queue size. So how are we doing? I hope you are understanding this, right? This hash whatever we have put, this is actually comments. So ns queue limit n0 to n1 10. So what is this queue limit? If you if you try to put more than 10 packets in the queue, it will actually get dropped. That means the packets more than 10 will not be retained in the queue. So this is the maximum capacity of the queue. We have 2 queues, right? 0 to 1 and then 1 to 2. That's why we are creating 2 queue limits here. Clear? And we know, right? So to communicate between any 2 nodes, we need 2 important protocols. What are they? First one is transport layer protocol. Second one is application layer protocol. There are many other protocols, but these are the 2 important protocols that we need to understand, right? So yeah, this one we checked, queue limit we checked, and these are the 2 important protocol, transport as well as application layer protocol. Here we are actually setting up the transport layer protocol, and here we are actually working on the application layer protocol. Now let us see how are we doing this one. How to set up a transport layer connection. See, set TCP 0 new agent TCP. What are they? So we know that all classes actually belongs to simulator class, right? And here what is happening within the agent class? Okay, here we have, right, within the agent class we are creating the subclass TCP. Within the agent class we are actually creating the subclass TCP and also creating the object TCP0 in object of subclass TCP. Clear? We are creating the object of TCP0, and what are we doing? We are actually attaching that attach agent N0. That means this TCP0 I am attaching it to the node N0. What does it mean? This all features of this TCP, right, will be applied to that node. That means now that node will follow the TCP protocol. That's what this attach means. The same way I am actually doing it for TCP sync, and I am attaching it to N2. Okay, and then what am I doing? I have attached it to source and destination, and now I have just connected the TCP0 and then the sync 0. Okay, so now I have set up the transport layer connection. Here set up the application layer traffic. Okay, so here anyway you know, right, we have another, what is the other alternative? Either you can use TCP or UDP. Here we are using the TCP. And for application layer traffic we are using CBR, that is constant bit rate. This CBR stands for constant bit rate. So yeah, we have new application traffic CBR. This is the syntax of it. Set type CBR, and then we are defining the packet size as 100, rate is 1 MB, and then random is false. You have to observe here you have underscore and then one space. Okay, you have to follow the same spacing. Okay, otherwise it will not work. You have a space here, you can observe it. Okay, and then yeah, you are attaching this to agent TCP0. Why only TCP0? Because you are actually generating traffic from here only. That is your source node, right? That's what I have named it also, TCP source. So that's why you are attaching it only to this node. You are not attaching to other nodes. You are attaching it only to this node. Clear? That's why you are attaching it only to source node. So now I have the TCP0 set class underscore 1. What are we doing here? Here we are basically scheduling the events. So when exactly it should generate the traffic, when exactly it should generate the packets which needs to be sent across the network. It will actually start at the time 0.0. That means as soon as you run this program, it will actually generate this particular traffic. Means this many packets. So SEBR 0 start. Okay, so this is the function which you are going to call, right? So where do you have this one? SEBR 0, right? You have it here. And then you are going to call finish at time 5. You are doing it for 5 units of time. Okay, simulation is going to run for 5 units of time. I'll just show you how where exactly you can check. So this you are going to finish it. We are going to call finish. So we saw that finish procedure, right, in the beginning itself. Yeah, proc finish. Here it is, finish procedure. What are you doing here? ns trace nam file, and then dump all the trace data and close the files. You're going to dump everything and close the files. So flush trace, you're going to flush all the data of the trace file, because for every simulation it will create the new files. And then close end trace, it will update the new content. Okay, so close nam file, you're going to close that, and then execute the nam animation file. So that means you are going to execute nam program 1.nam file. This whatever we created, right, and whatever the data it has, it will create this one, and it will show you the output. This is how it will show. As soon as you execute that, it will open this particular animation window. Here you have stop, play forward, play backward, and then fast forward, fast rewind buttons. See, this is what I told you. You actually called it for, you are starting it at 0, and then you are calling the end time at 5, right? So that means, see here, 1, 2, 3, 4, 5. You are running it for 5 units of time. Clear? And whatever you created, it's actually coming here. Here you can actually increase or decrease the speed of the simulation. Okay, so these are all like, this is like a just like some player only. You can now play around with it so that you will be more familiar. This is what you are doing it here. Okay, you are executing the nam file, so that the execute nam animation file, it will show you the animation, and then you have to print number of packets that got dropped. Show the number of packets dropped. So where do you find that? You will have, we created one more file, right? Along with nam, we created the trace file. That means show the number of packets dropped. So echo the number of packets dropped is, number of packet drops is, like you will actually print this one, and then using this grep, this is the command that you are using, grep command, to count the number of packet drops in your trace file, right? Wherever you find this one, this D, okay, this upper, what do you call it as, this shift D, okay, whenever you find this one, like that means it indicates a packet drop. So you count that and you print it as number of packet drops. Okay, so that means you are finishing this particular program, and then you will, this is what, right, the finish procedure. Then what are you doing? You're running the simulation. So this is your code. Right, now you also know how the animation looks like, animated output. Now let us execute and see in real how exactly it looks. And before that, one more thing, see here, we have to actually change few things whenever we are seeing the output. We will actually change, you need to modify the bandwidth. We are giving the link bandwidth as 1 MB, right? We'll see what happens if I change it to 2 MB, whether my packet drops will increase or decrease. Of course it should decrease, right, because capacity is increasing means number of packet loss should be less. And also we modify this one, that's why we have already given the comment here, queue length. If you have lesser queue length, of course drops will be more, packet drops will be, and if you increase the queue length, it will be less, right? You can modify these two parameters and check the output. Let us see the execution now. Logged into Ubuntu. Let me open the terminal. So let me write, now I need to write the code, right, for network simulator. So I am using VI editor, VI. I'll name the program as file name as ns1, network simulator first program. So ns1.tcl. TCL is the file extension here. Okay. So here you have to write in the code. So let me just paste the code that I have copied. So here the file extension that we gave is .tcl. Okay, so yeah, here is the code, and in this VI editor, I hope you all are aware of it. You have to press I, that means insert mode, only then you can type in here, and you have to actually move your arrow keys to go to next line and change something there, and then at the end just click escape, colon, and then WQ to save and quit. Okay, that means you have to press escape, colon, WQ. Okay, so that means you will come out of it, you will come back to this console. Now let me run that one, ns filename.tcl, that is ns1.tcl. So here I got my output screen, that NAM file actually, right, whatever I have already explained, it creates this output screen. You have play, forward, backward, stop, all these messages. So I have started playing it here. So that means it is like the whatever you can see, the front, see whatever the packet, it got dropped now. Okay, the packet got dropped, and whatever the forward blue marks that you see, it's actually the packets that are getting delivered. So whatever from source you can see some drops, right, that is nothing but your packet drop. Okay, so you saw, right, first and second two, we saw one more packet got dropped just now, so that is your packet drop. And yeah, it's actually the and whatever the small ones that you see, right, the down the second row, that is nothing but your acknowledgement. Okay, so that is your acknowledgement, whereas the forward one, the bigger blue marks are your packets. So that means your simulation got succeeded. Now let me stop that, because we had defined a predefined time, right? So yeah, so see, you can see that here, right, the number of packet drop is 8. The number of packet drop is 8. Okay, so that means, let me see from where did it fetch that packet drop. See here, these are the two programs, program 1.nam, program 2.trace. So and in this trace file, using this nam, we saw that user interface, right? Now using this trace file, we can see how many packets got dropped. Here whatever, just search for D. all the packets that are that got dropped. You can see, right, 1 of 8. That means 8 packets. I have 8 packets dropped in this tray log file. So it will actually fetch this particular number of rows where I can find the D, and it will actually report me there. Okay, so you can open your NS file from here as well in gedit, because it would be easier for you to edit and save. I just opened the program. So now I'll do one thing. I'll just alter few parameters. As per our program, we need to alter and check the output, right? So let us see. Let me change the queue size. Okay, I'll just by default I had given 10. Okay, in the first run. Let me change it, and let me take some other value. Let me take 5. Okay, I'll just change the queue size to 5. That means, so what is the expectation now? My packet should be, the packets that are going to be dropped will be more, because my queue size is 5. The capacity of the queue has been reduced. Let me just run it again. Let me run ns1. Can you see the number of packets drop is 16 here? Let me just run the simulation, the animation part of it. Yeah, you can even observe here. Anyway, we saw that count, right? See, number of packets that are getting dropped or more here. Anyway, we saw the number on the console as well. Number of packet drop is 16 when I reduced the queue size. We observed that, right? And let me complete this run. So forward ones are packets, the smaller lines are acknowledgement, and the blue that are getting dropped from TCP source is nothing but the packet drop. Yeah, my simulation run is over here, right? So let me now I need to change one more thing, right? Channel bandwidth. What is my channel bandwidth? Let me change. I'll just do one thing. I'll put the queue size back to 10, so that it would be in the initial condition only, where I had got 8 packets dropped. Right, for the same condition, I'll just change my channel capacity. Okay, so let me change that to 10 first. Yeah, so here I'll first change the channel capacity. First, both I need to change anyways. So queue limit, I'll change it back to 10. Same for this one also. And bandwidth, I'll change it to, I'll do one thing, I'll just change it to 2 MB. Okay, I'll just change it to 2 MB both. Let me just save the code and run again. So how do I run? Escape : WQ. That is the command that I need to use. That is the shortcut for saving and then closing your window here. Okay. Yeah, it got saved. Let me run the program. ns1.tcl. So that is the command here. ns1.tcl. Okay. Let me run the program. Just press enter. See here, now it is 0. That means none of the packets are actually getting dropped. Just observe in the animation also, you don't see any packets that are getting dropped from source, because now the channel capacity has been doubled with the same old queue size. But still, as the capacity itself is doubled, even with the same queue size, we can achieve complete throughput. Like we can experience 0 packet drops, no packet loss at all here. So yeah, you observed it, right? Even in the console we saw it's only 0. We saw that, right? The number of packet drop is 0. Clear? So now Let us see the trace file. Trace file gets updated every run. Okay, let me just open and see the trace file. Program prog1.tr, right? So that is my nam file, and then yeah, here is my trace file. You can see that in the home page. Okay, it will get created where you had saved the program. You just do Control F, search for D, the line, the word, I mean the letter D. There is no rows actually. That means no packet loss. Okay, so this is all about the execution part of it. Just practice it couple of times so it would be easier for you to analyze. Thank you.